Assalamu alaikum students, hope you all will be fine. In first chapter we study about operations on set, Venn diagram and different operations, different properties etc. Now we start second chapter which is named as squares and square roots. In this chapter we study about the properties of square and perfect square, find the square root of natural number, find the square root of decimal number, square root of the vulgar fraction. So our first topic is rational number. Rational number Q are numbers that include integers and fractions. It means that the rational numbers are from the integers. Rational numbers can be expressed in the form of P by Q, where P and Q are integers and Q is not equal to 0. Rational numbers are represented by the set Q. Q is equal to -1, -1 by 2, -1 by 3, -1 by 4, 0, 1 by 4, 1 by 3, 1 by 2 and so on. Next, an irrational number cannot be expressed in the form of P by Q, where P and Q are integers and Q is not equal to 0. Irrational numbers are represented by the set Q. Here a set we have minus square root 12, minus square root 5, square root 2 by 5, square root 2, square root 1 by 1.6, square root 5, square root 7 and so on. For example, under root 2 equals to 1.4142135 and infinite. It means that this is an irrational number because this is not right in the form of P by Q and this is an infinite value. Under root 3 equals to 1.7320500870 and so on. This is also an infinite value and not written in the form of P by Q. Under root 37 is also an infinite and not written in the form of P by Q. Under root 8 equals to 2 under root 2. We take under root 2 and then multiply it by with 2. The value is 2.828 and then so on. It is also infinite value and not written in the form of P by Q. Pi is equal to 22 by 7. 22 by 7 is 3.14 and so on. This is an infinite value and not written in the form of P by Q. Rational number can be written in the form of P by Q and Q not equals to 0. For example, under root 4, 9 and 16. Ratio word derived from rational number. It means m ratio n equals to m by n. This is a fractional form. So when we take under root 4, we get 2 and denominator is 1. So it can be written in the form of ratio 2 ratio 1. Under root 9 equals to 3 and denominator is 1, 3 ratio 1. So this can be written in the form of P by Q. These are the rational number. The set of rational and irrational numbers constitute the set of real number. It means that when we get union of rational and irrational number, we get a set of real number. There are two properties of irrational number. The first property we have non-terminating, means the number of digits after decimal point is infinite, and second is non-recurring, means there is no repeating pattern of digits in the quotient. First example, according to the first property we have 2 by, when we divide 2 by we get 0.6666. It means that 666 is a repeating value and non-terminating because continued so and not end. In other words, infinite, so this is a non-terminating decimal. And according to the second property we have a value which is 1 by 7. When we divide 1 by 7 we get 0.142857. which is also non-terminating but recurring. Recurring mean these values are not repeated. See the difference. Example number 1 and 2, we have a repeating value in this, and this is not a repeating value. So according to the first property, non-terminating, and second property, non-terminating but recurring. Next topic, we have squares. The square of a number is the product of a number multiplied by itself. The area of a square, for example, it is calculated by finding the square of length of its side. The square of a number n is expressed as n square or n raised to power 2. Next we have perfect square. The perfect square of a natural number, for example 1, 2, 3 and so on, is called perfect square. The prime factor of a number which is perfect square always form pair. For example 1764, 1764 is a perfect square because its prime factors are 2 multiplied by 2, which is in pair, 3 multiplied by 3, then 7 multiplied by 7. We see that 2 is in pair, 3 is in pair, 7 is also in pair. On the other hand, 854 is not perfect square because its prime factor 2 multiplied by 7 multiplied by 61. We see that there is no pair of 2, 7 or 61. For example, 36 is a natural number and also a perfect square because 36 is a perfect square of 6. When we multiply it by 6 with 6, we get 36, which is a perfect square. So 6 is also a natural number. Let we have another number 11, which is a natural number but not a perfect square, because when we multiply it by 1 with 1 we get 1, 2 multiplied by 2 we get 4, 3 multiplied by 3 we get 9, 4 multiplied by 4 we get 16. So 11 is not in between 9 and 16. So 36 is a perfect square of 6, but 11 is not a perfect square of any number. So this is a perfect square and this is not a perfect square. The next topic is properties of squares and perfect square. We have table. According to this table we see the properties. The first property is a number which is perfect square will always have 0, 1, 4, 5, 6 or 9 as its unit place digit. For example, 16 is a perfect square, 81 is a perfect square, 36 is a perfect square and 25 is also a perfect square. You can see that the unit value is 6165 from this. So it means that 0, 1, 4, 5, 6 or 9 in the unit place of the perfect square. Second property, we have the number of 0 at the end of a number which is perfect square is always even. It means that when we take square of 10, the perfect square is 100. It means that the last or end value we have 0 on the both square and perfect square. Similarly, 30 square is 900, 20 square is 400. At the end you can see that both values have 0. The next property, we have the square of an even number is always even. 4 square is 16 and the both are even numbers. Similarly, 6 square is 36, 12 square is 144, both are the even number. Next property, we have the square of an odd number is always odd. It means 5 square, which is odd number, is equal to 25 and 25 is also an odd number. Similarly, 7 square is equal to 49, both are the odd number. 11 square is equal to 121, both are the even numbers. The next property, we have the square of the number except 1 is either a multiple of 3 or exceed multiple of 3 by 1. Next, the square of a number except 1 is either a multiple of 4 or exceed a multiple of 4 by 1. According to the property, when we divide 4, which is a perfect square, by 3, we get 1. 9 divided by 3, we get 1. 16 divided by 3 we get 1, 25 divided by 3 we get 1, 36 divided by 3 we get 0. It means that when we divide perfect square by 3 we get 0 or 1. Similarly, when we divide perfect square by 4 we get 0 or 1. So when perfect square are divided by 4 or 3 we get only 0 and 1. If we have another value excepted 0 or 1, it means that there are not a perfect square, because all of the perfect square when divided by 3 or 4 get 0 or 1. The next property we have, there is no perfect square which is double of another perfect square. It means that when we double perfect square, 4 is a perfect square, 4, when we double 4 we get 4 plus 4 which is 8, so 8 is not a perfect square. Similarly, 16 is a perfect square. When we double 16, 16 plus 16 we get 32. 32 is not a perfect square. Next property we have, the square of a proper fraction is less than itself. It means that we have a fraction 3 by 5 and the square of a fraction is 9 by 25. And when we solve by cross multiplication we get 75 which is greater than 45, or when we equal the denominator of the both fraction, multiply 3 multiply 25, 5 multiply 25, we get 75 by 125. Similarly, 9 by 25 multiplied by 5 we get 45 by 125. And if we see that the 75 by 125 is greater than 45, it means that the fraction is less than itself. Next property we have, the square of a decimal less than 1 is less than itself. If the value we have less than 1, for example we have 0.5 which is less than 1, when we square the 0.5 we get 0.25. It means that 0.25 is less than 0.5 and less than itself. So the square of 0.5 is smaller than itself. Next we have square root of natural number. Square root of a natural number n is the number that produces the number n when multiplied by itself. The square root of a number is denoted by radical symbol. It means that the sign of the square root is this. It means that square root is equal to 1 by 2 and n means the number of the square root. For example, the square root of 9 is 3 and expressed as square root 9 is equal to 3. And the square root is equal to 1 by 2. So when we factorize 9, 3 3s are 9, 3 1s are 3, we get 3 square. 3 square multiply with 1 by 2 which is a value of square root. 2 cut with 2 we get 3. Square root 9 is equal to 3. The number inside the square root symbol is a radical. It means that the number in the square root is called radical. 9 is a radical. The square root of a number that is perfect square can be found by the prime factorization method. So when we factorize 9 by 3, we say that this is a prime factorization method. For example, we have a digit 4. The square of 4 is 16 and the square root of 16 is 4. This is a symbol of square root which is also called under root. Square of 4 equals to 4 square. 2 is a power and 4 is a base. Square root of 4 is under root 4 or square root 4. Under root equals to 1 over 2. So 4 square and the square of 2 cancel with the power of under root which is 1 over 2 and we get 4. Here 4 is a base and 2 is a power. methods to find square root, there are the two methods, prime factorization method and the division method. In prime factorization method, firstly find all prime factors. For example, we have a value 225. The summation of 225 is 9 and 9 is divisible by 3. So 225 is also divisible by 3. 3 sevens are 21, 1 carry, and this is 15. 3 fives are 15. Now the sum of the 7 and 5 is 12, which is also divisible by 3, and 75 is divisible by 3. 3 twos are 6, 1 carry, 3 fives are 15, and then 25, which is divisible by 5. 5 fives are 25, and then 5 ones are 5. So we have prime factors. And the next point is make pair of factors. So these are the factors and we make pair of 3 and pair of 5. In the next, choose one prime number from each. It means we make factor and choose only one prime number. We have a prime factor of 5 and choose only 5. So next, product all those prime factors. So we multiply 3 with 5 and get product, which is 15. Square root 225 equals to 15. Second method is division method. Make pair from right to left. Even number have complete pair, odd number have not complete pair. It means we have value 625 and we make pair from left to right. 25 in pair, 6 is not in pair because 6 is a single value. So the next is number whole square is equal or less than number. It means that we take a values which multiplication equals to or less than this number. We take 2 because the multiplication of 2 is less than 6. If we take 3, the multiplication of 3 is 9, which is greater than 6. So we take 2, which multiplication is 4. Then subtract the product. We subtract 4 from 6 and answer is 2. Then bring down the next pair. The next pair is 25. Bring down the pair and the value becomes 225. Double the quotient means double this values. 2 plus 2 equals to 4. So here we write 4. So we have the value 225. See the last digit of this value, which is 5. So we have the square of some values. Look at these values. In these values, which one have last digit 5? So the 5 square is last digit 5. So then 45 multiplied by 5 and get 225. So the under root 625 equals to 25. And 25 is a answer. For a number that is not a perfect square such as 3, the square root is found by using the division method. It means that some values which are not having a perfect square, we divide 3, we find square root of 3 by the division method. In division method we have 3, we get a value as well as quotient and divisor. So 1, we get 1 as well as quotient and divisor. 1 ones are 1, subtract 1 from 3, we get 2. Now because we have a lesser value, we get 0 in pair. Now bring down the pair, we have 200, then double the value and plus 1 with 1, so we have 2. The next value we get as well as quotient and divisor, we get 7. So 27 multiplied by 7, we get 189. Then subtract 189 from 200, we get 11. Bring down the another pair, then double the value. For doubling the value, we add 7 with 7, 7, 7, 14 and 1 carry, which is 2 and 1, 3. Now we get another value which is in circle as well as quotient and divisor. Now 343 multiplied by 3, we get 1029. We subtract 1029 from 1100, we get 71. Now bring down another pair and double the value, which is 3. 3 plus 3 we get 6, and the value in circle as well as quotient and divisor. So multiply this value with 2, we get 6924. Now subtract 6924 from 7100, we get 176. Now bring down the pair and double the value 224 and make another value as well as quotient and divisor. It means that this process is a non-terminating because the value is continued. So we can say that square root 3 is equal to 1.73 rounded off the nearest two decimal places. So this is an example of not a perfect square because 3 is not a perfect square. Question number 2. State whether the following true or false. 100 and 200 are perfect square. This statement is false because 100 is a perfect square of 10 but 200 is not a perfect square. Next statement is the square root of an even number is always even. Because we have 4 square, 4 is an even number and 4 square is equal to 16, which is also an even number, and 16 is a perfect square. Next statement 2.31579 and so on is irrational number. This is true statement because this value is infinite. It means that this is an irrational number. Next statement we have the square root of the 345 contains 2 digits. When we find the square root of 345, first if we make pair, then value as well as quotient and divisor, 1 ones are 1, we subtract 1 from 3, we have 2, bring down the pair which is 245 and double the value 1 and 2 and get 8 as well as quotient and divisor. Multiply 28 with 8, we have 224. Subtract 224 from 245, we have 21. It means that this is not a 2 digit because this should be continued. So this is a false statement. The last statement, which is the square root of 400 is 20. So when we multiply 20 with 20, we get 400. It means that 20 is a perfect square of, it means that square root of 400 is 20. So this is true statement. Okay students, Allah Hafiz, take care of yourself.